Hello students, welcome to Aptdemy's online class. Today we are taking a physics class now. We have got a request from students, our students, to solve a particular problem. I have taken up this problem. I found this problem to be interesting and it is useful for online platform. So I thought I'll cover this problem in today's class. But regular students, you are actually observing our uploaded videos and class notes, and hopefully you are solving the questions that we have given to you. You are working on the problems. And in case if you find any difficulty in solving any problem or in understanding the recorded videos, course material, let me know, let us know. We will try to take separate sessions for that so that you can get clear understanding on whatever you have provided to you. So fully utilize our platform and get benefited. Okay, so let us take today's problem. It is a problem in the field of gravitation and rotational motion. Let us see what the problem is. See, try to understand the problem very clearly. It is a very fundamental problem. And I just want to extend my thanks to that guy who has actually requested me to solve this problem. It's really very interesting and fundamental problem. Three particles, each of mass m. Just let me. Three particles, each of mass m, are situated at the vertices of an equilateral triangle of side length L, the side length A. Next line is interesting. The only forces acting on the particles are their mutual gravitational force. It is quite unlikely a situation, but okay. The problem says that there is only force acting on the particles are the mutual gravitational force. It is desired that each particle moves in a circle while maintaining the original mutual separation A. Find the initial velocity that should be given to each particle and also the time period of circular motion. Okay, so fundamental thing is that three particles, they are situated at the vertices of an equilateral triangle of side length A. Side length A. So this length is A, this length is A, this length is A. They are not connected. So one particle of mass m is situated at A, another particle of mass m is situated at B, another particle of mass m is situated at C. Vertices of an equilateral triangle. Now, only force experienced by each of the particle is the mutual gravitational force. So there is no Earth's gravitation. We have to rule out any other force from this environment. It's a hypothetical problem, but fundamental. That means this mass is experiencing a gravitational pull of this mass in this direction, and this man is experiencing a gravitational pull of this mass in this direction, because you know, if there are two masses m1 m2 and if the separation is d, then the force of gravitation is actually g m1 m2 by d square. And this is attractive force. That means m1 attracts m2 in this direction and m2 attracts m1 in this direction. So these two forces will act. So there will be net. So these two force vectors are acting. So there will be net force acting in this direction. Similarly, for this particle, there will be net force acting in this direction. We are not telling anything what this direction is. You have to find out. And there will be net force acting on this in this direction. And we want this particle to execute a circular motion, maintaining their relative position. That means even if they are disoriented, then they maintain the condition of equilateral triangle. that means separation between them remains intact. That means when they are disoriented also, they are sitting on the vertices of equilateral triangle. This is fundamental. And we want a circular motion to execute. The particles should execute a circular motion. Then what to kick off a circular motion, to begin a circular motion, how much velocity should be given to each particle? And if it executes a circular motion, then what is the time period of circular motion? Time period means in how much time one revolution is completed. Say for Earth, it takes 365 days to revolve around Sun. So you know what time period is. So with this background, let us try to solve this problem. So what we do when the particles are at, let us do some background work. So in the background work, what happens when the particles are at A, B, and C position? Then just let me calculate where its center of mass is located. So for that, we make a convenient coordinate system for our choice. You can choose any coordinate system, but I should select a coordinate system which is convenient to me, convenient for calculation. So I choose a coordinate system like this. So let me select the white color. So this is x coordinate. This is x-axis. This is x dash, negative x-axis. This is y-axis. This is y dash. And I take the origin of the coordinate system at the midpoint of line BC. This is the equilateral triangle whose side lengths are A, and A. Okay. So if this is midpoint of the line BC is chosen as the origin of the coordinate system. So coordinate of origin, the midpoint of BC is definitely 0, 0. And then what is the coordinate of C? It is A by 2, 0. This is minus A by 2, 0. And what is this? What is the coordinate of this? This is the height of equilateral triangle. And you know these angles are 60 degree. Because it's the equilateral triangle. This angle is 60 degree, this angle is also 60 degree. So H by A, this is all you know, but just let me write down. It is sine 60 degree. So H is actually root 3 by 2 A. Okay. From Pythagoras theorem also you can calculate H is equal to square root of A square minus A square by 4. So it is A root 3 by 2. Anyway, H is A root 3 by 2. So what is the coordinate of A? It lies on y-axis. So its x coordinate is 0 and y coordinate is A root 3 by 4. It is by 2, sorry, it is 2. Because height you have calculated is 2. So it is A root 3 by 2. So, three masses located at three equal masses M located at A, coordinate 0, A root 3 by 2, A by 2 0, minus A by 2 0. What is the coordinate of center of mass? Center of mass, you remember, coordinate of center of mass of system of particles can be calculated using this formula sigma mi xi divided by sigma mi, and y bar is sigma mi yi by sigma mi. So here in this case, what will be the coordinate? It will be 0 plus a by 2 minus a by 2 by 3, because all masses are equal. So m into 0 plus m into a by 2 plus m into minus a by 2 divided by 3m, because sigma mi in our case is m plus m plus m. Only three masses are there in the system. So x bar is how much? 0 plus a by 2 minus a by 2 by 3. So it is 0. Is it not? And what is y bar? The y coordinate of center of mass is a root 3 by 2 plus 0 by 3. So it is that divided by 3, because m they cancel from the expression. So it is 1 by a by 2 root 3. Okay. So the center of mass, all for the time being, it is G. So coordinate of G is how much? 0 a by 2 root 3. Now since this is equilateral triangle, it has a huge significance. We'll try to understand. We are not assuming any previous knowledge in this subject. Whatever you do, you derive the formula and discuss. We are not using any formula ready. Everything will derive and explain to you. Now, this point, this is the center of mass. Now, just calculate distance h. A's coordinate is 0 root 3 by 2, 0 root 3 by 2, and this coordinate is 0 a by 2 root 3. So AG, distance AG is how much? Is a root 3 by 2 minus a by 2 root 3. A by 2, in the denominator there is a root 3. So it is. Okay. So I can write it is a by 2 root 3 minus 1 by root 3. So it is what? It is a by 2 root 3 into 3 minus 1. Is it okay? So it is 2, they cancel each other. So I am left with this a by 2. So AG's value is a by 2. Now see what is the value of BG. What is the distance of G from this mass? These are all point masses, okay? So B's coordinate we know minus a by 2 0, and G's coordinate we know it is G's coordinate is 0 by 0 a by 2 root 3. So what is the distance BG? Simple. So it is a by 2 whole square plus a by 2 root 3 whole square. So what I can do, I can take this a by 2 common, out of square root it is coming, so it is 1 plus 1 by 3. So what is this? A by 2, 4 by 3. So square root of 4 is 2, so these two cancel, so ultimately I am left with a by root 3. Here also I got a by root 3, here also I got a by root 3. And what is CG? CG is a by 2 0, and G's coordinate is this one. So again square root of a by 2 whole square plus a by 2 root 3 whole square. So again it is a by root 3. So it's a very important information I got. AG is equal to BG is equal to CG, and that is equal to a by root 3. So the center of mass of these three masses is equidistant from all the three particles. This distance equal to this distance equal to this distance. Okay. Moreover, see, G's coordinate is a by 2 root 3. That means G, if we call this point as O, this is the origin. So OG is how much? Because G's coordinate with respect to this coordinate system, O is the origin. G's coordinate is 0, A by 2 root 3. So OG is A by 2 root 3. Whereas OA is A by 2 multiplied by root 3. So what is OG by OA? OG by OA is what? OG by OA is actually A by 2 root 3 multiplied by 2 A root 3. Is it okay? So it is basically these two cancel, these A cancel, so it is 1 by 3. So OG is 1/3 of OA. OG is 1/3 of OA. But what is OA? O is the midpoint of this line BC. Is it not, for equilateral triangle? So it is a median. And G cuts the median in the ratio. This side it is 2, this side it is 1. So actually AG is to OG is actually 2:1. So AG by OG is actually 2:1. So G happens to be the centroid also. Where centroid of a triangle means where the three medians of the triangle intersect. So this is centroid of the triangle ABC. This is center of mass of ABC. And another very interesting, since GA is equal to GC equal to GB, so this is the center of the circumcircle of this triangle. So if I draw a circle like this, so its center happens to be at G, because GC is equal to GA is equal to GB. So this is the center of the circumcircle of the triangle ABC. Okay, so the radius of the circumcircle is actually AG is equal to BG equal to CG is equal to A by root 3. So radius of the circumcircle is A by root 3. And center of the circumcircle lies at the center of most of these three particles or at the centroid of the triangle ABC. Up to this it is okay. So three masses ABC, they are not connected at all. So their centroid is equal to the center of mass is equal to the center of the circumcircle, and the radius of the circumcircle is A by root 3. Okay, let us keep this data in mind and go to the next step for calculation. So R is equal to A by root 3. So let us keep this in mind. So R is A by root 3. We derive this expression in the earlier slide. Okay. So now what happens? Let us calculate the force acting on the particle. So because of presence of A, B experiences a force in this direction, gravitational force. And what is that force? If I call it F. So F is how much? G M into M divided by A square. A is the distance between them. So it is G M square by A square. So this force is acting on B in this direction, and magnitude of that force is Gm square by A square. Now resolve this force into two components. Okay. So what happens? This force, this angle is how much? It is 60 degree. Okay. And let us not resolve in these two directions. What we do, we just change this. This is gm by a square. I take this line, this median. We consider this median. So let it be cutting the AC at M. So what is the component of this force? Why I am taking the component along this, that we are trying to explain. So on B, how many forces are working? This is actually F1, we call this F1, which is actually G m square by a square. Another force B is experienced due to presence of C in this direction. So point B or mass B, mass at B is experiencing two gravitational forces, one due to presence of A along this direction, which I call F1, and another force F2 in this direction, which I call F2. And value of F2 is again G m square by a square. So I want to add the forces F1 and F2, vector sum. So what do I do? So I take a different approach. What I do, I take the component of F1 along the median, this direction, and I take component of F2 along the median. Median means along BN. So component of F1 vector along BM is how much? F1, what is this angle? This is 30 degrees. This is 30 degrees because these two triangles are congruent. Because this is the midpoint. Why they are congruent? Because this is the midpoint, this is the median, and this angle is 60 degrees, and this is actually cone side, and this side is equal to this side. These triangles, and this is the midpoint. This side is also equal to this side. So these two triangles are congruent, and this angle happens to be 90 degrees. So this angle becomes 30 degrees. Okay, this angle is also 30 degrees. So the force F1 has a component along BN is F1 cos 30 degree. Okay, and component of F2 along BN is F2 cos 30 degree. And there are two components of the force. One is along BM and BM. Another must be perpendicular direction to BM. So this component will be F1 sin 30 degree. This component is F1 cos 30 degree. This component is F1 sin 30 degree. And similarly, F2, which is in this direction, it has two components. One is along this direction, another is perpendicular to this direction, and that is F2 sin 30 degree. But see, magnitude of F1 and F2 both are same. Okay, both are equal. Therefore, F2 sin 30 and F1 sin 30, they cancel each other. So the net force, gravitational force, it acts along BM. So net force on B is acting along BM. That means it's acting along the median. And what is that? Just some force. Because this is F1 cos 30 plus F2 cos 30 degree. Okay? This is okay. So it is how much? Since F1 and F2 both are same, so I can write G m square by a square and 2 cos 30 degree but cos 30 degrees is root 3 by 2. So I get ultimately root 3 gm square by a square. Can I write like this? Root 3 gm square by a square. So this is the net force acting on B is root 3 gm square by a square. I think calculation is correct up to this. Now see, this force is acting along the median. Similarly, same treatment if I apply to C, then the resultant force will definitely act along the median in this direction, and its magnitude again will be same. If you calculate, it will be same because in no way the particular C is different from particular B. Same situation, identical situation. So it is, and similarly, if A will be what? Root 3 g m square by a square. So what we conclude from all this thing, from these three expressions? So all the masses, they experience equal force towards the centroid of the triangle. Okay, that means towards the center of the circumcircle of this triangle ABC. So what happens? So these forces, just let me remove all these things. So we have calculated the force, it is equal. So we are slowly approaching towards the situation of the ideal circular motion. So what happens? In ideal circular motion, what happens? There is always a constant magnitude force acting towards the center. So here the center is the centroid of the triangle. So I discovered or found that always there is a force towards the centroid of the triangle whose magnitude is equal for all the three particles. Now, to make a circular motion to happen, if you recall your basic rotational motion understanding, which you already have covered and you have worked out our problems probably. So when the particle executes a circular motion, it maintains a constant speed v. Velocity changes tangentially. Always it is tangential, but direction every moment is changing. But the magnitude of the velocity remains same. And there is a constant force towards the center always, which is perpendicular to the tangent or the instantaneous velocity of the particle. And if some agency supplies this constant pull towards the center, then this motion can happen with a slight kick, with a slight initial velocity v in this direction. And what happens? The condition is mv square by r. The required centripetal force necessary for this circular motion should be provided somehow. So mv square by r should be equal to fc, centripetal force. Now what happens in our case, I find that since it is this circumcenter of the triangle, there is a circumcircle, and circumcenter of the circle is the center of the triangle ABC, and it is a fixed point. So wherever if A moves to this point, B moves to this point, C moves to this point. So again you take this triangle, or A moves to this point, B moves to this point, C moves to this point. So it is A dash, B dash, C dash.
Yeah, C dash.
C dash. So ABC triangle just rotated by the circumcircle, circumcenter of the circle, or the centroid of the circle remains fixed at this point. Therefore, the center of the circle is fixed, which is nothing but the centroid or the center of mass or the center of the circumcircle of the triangle. So it is a fixed point, and always the particles at ABC experience force in that direction. So it is the ideal condition for circular motion. Only thing is that you have to give a kick to this particle, to this particle, to this particle in this direction. If you give a velocity v, equal velocity, here also if you give a velocity v and if you give a velocity v, then they will start rotating. And the necessary centripetal force will be supplied by this. So when such situation happens, if mv square by r becomes equal to this root 3 gm square by a square, then this circular motion will start happening. So many practical situations are there. Say motion of a charged particle in a magnetic field. If you give an initial kick, then the charged particle will keep on rotating the magnetic field, circulating around the magnetic field, which is in this direction, and particle will move like this. This is an ideal situation over here. So what happens actually? So uh, now what is happening, or we have already calculated. So I simplify this expression. So 1m goes actually. So v square equal to root 3 gm into r by a square. Is it not? So v square equal to root 3 gm r by a square. But r value we have already calculated. So it is r is a by root 3. So if I substitute root 3 by a square gm, r is a by root 3. So root 3 cancels, so I get gm by a. So v becomes root over gm b. So this much velocity, if you give initial velocity, then it should be tangential to the circumcircle. Then what happens? It should be tangential to the circumcircle. That is essential. Though direction, the question, it has not been asked what direction the velocity to be imparted, but every point the velocity to be given along the tangent of the circumcircle at ABC. And if you give this, immediately it will start executing a circular motion, and the necessary centripetal force will be given by the mutual gravitational force when they are added. So I get the answer V is equal to root over gm by a. I think there is no doubt, but there is another part of the problem. What is the period of rotation? What is the period of rotation? So for that, what do we do? Just to think, v is the speed, constant speed, uniform motion. What is the speed v that we have calculated? Now v is equal to speed, uniform speed in circular motion, which is a linear speed. It is related to the angular velocity by this relation, v equal to r omega. R is the radius of the circle along which it is executing the motion. And we have found out the value of r is a by root 3, and omega, you know, it is always 2 pi by t. T is the time of revolution in circular motion. So t is how much? 2 pi a by root 3 into 1 by v. But v is this much, so it is 2 pi a by root 3 into this 1 by v, so it is a by gm. Okay, so it is what within bracket, within square root, there will be a cube sort of thing, because this a will go as a square inside the root, and there is root 3 multiplied by root gm, so in the denominator will be 3gm. So period of circular motion is 2 pi multiplied by a cube by 3gm. So this is the period of motion. So this is the answer, 2 pi square root of a cube by 3gm, and velocity is root over gm by g. So this is the problem. So you see, this is a problem where basic mechanics is involved, concept of rotational motion is involved, and concept of geometry is involved. And these type of problems where mixed concepts are there, they are generally given in some competitive, top level competitive exams in India and abroad. So I think this is a fantastic problem. If you go through the problem carefully, understand the concepts, then you can handle similar type of problems on your own actually.
Thank you, sir, for your good explanation.
And please go through our problems which we have provided in Aptdemy's e-platform. So go through those problems, work out those problems. If you find any difficulty, let us know. We will help you in solving those problems.
We will come back to some different problems.
Okay. Thank you very much.